In this set of lectures, we will look at the shell, and specifically the bash shell. We'll try to talk about shells in general, but for this course, we're pretty much sticking to bash. One thing you want to note is that some of these tools were created about 40 years ago, and they're still very much in use today, and of course, they've been refined quite a bit since those early days. Oops. All right. So some of the things we'll talk about in this set of lectures, that is lecture 9. This is mostly from chapter 9, plus I've added some material. We'll look at the shell, what it is, and look at some shell variables, meta characters, a bunch of utilities. These are commands. And then we'll also look at what happens during startup, look at shell files or files that are used when shells start up. And we'll look a little bit at the corn shell, but not so much. We're really pretty much sticking to the bash shell, which stands for born again shell. And then lastly, we'll finish with a first look at Unix process management. This is something that we'll go into a lot more detail once we know how to write C programs. Okay, so what are the basic components of a Unix or Linux operating system? Mainly, Linux really is this kernel, which sits right on top of the hardware. Basically, the kernel is software that interacts directly with the hardware. It stays in memory from the point where the system boots up till you shut down the system. So as long as the operating system is up, the kernel is running, basically taking up quite a bit of memory. There are, in addition to the kernel, there's a number of modules, and these are utilities, and a lot of these stay resident in memory, so that's why they're called resident modules. These are parts of the operating system that stay running, sort of, and we'll use this term later. They are all running in the background. And the shell sits on top of that. What does that mean? That means that when you interact with the shell, that is, you type in commands, you are interacting with a program that uses many layers of the software. Of the operating system, so including the kernel, which directly interacts with the hardware, and various resident modules, which are also running as long as the system is up. The rest of the operating system is not always running, but exists as programs stored on disk and can be run, for example, as commands or by other utilities or by the users themselves. So through through programs that the user will run at the shell, you may load up programs or parts of the operating system that are not resident. They are sitting in the disk ready to be run. Okay, so I hope that gives you some idea of where the shell sits. So you interact with the shell, that is bash, and bash interacts with a bunch of things, eventually the kernel, and then after that the kernel interacts with the hardware. Okay, so what happens when you start a shell? Well, actually, how do you start a shell? On the live DVD, the way you start a shell is by running the terminal program, which is actually, although it's called terminal, the real name of the program is GNOME Terminal. So this is a program that starts up and runs a shell inside it. Another way that you can run a Unix, or another way that you can start up a Unix shell, is if you log into a server. At the other end of the server, there is a program that's always waiting for connections, network connections, and that program, as soon as you log in, starts up the shell. So you log in, and then you're interacting directly with the shell through the network. A third way that you can start up a Unix shell is to actually run the command for a shell inside another shell, and we'll see how to do that. Basically, the shell is just a program, and you can start any program from it in the shell if you have permissions for it. So roughly speaking, here is what happens inside a shell. The user logs in, let's say, or you start up a terminal, and the shell shows you a prompt. The user types a command. The shell searches for this program. If it finds it, it executes it, and the user interacts with the program. Let's say it's reads a few things, prints something out, and it's done. What happens is the shell gets control of input, and the shell shows another prompt. User types another command. Shell executes that program, and so on. You just keep going there until the user logs off. So that can be with an exit or Control D. Okay, so let's take a look at some of the shells that we can use. So let me just show you an example of how you can start a shell. So once you start up terminal, that's it. You've started up a shell. This is the very first command that we're about to type in. You can do things like ls and so on. So we've seen a bunch of commands. Couple of other things we can do is we could start up another shell. So let's just see. I'm not sure exactly which version of the live DVD you have, so you may or may not see these things. So let's try the C shell. You can just type C shell, CSH, hit return, and because you got this other prompt, you can be pretty much sure that you've started the shell. So what have you done now? You are running bash. You ran C shell inside it, and now you can execute a lot of the commands that you execute in bash. Not everything, almost all of them, and you'll see slightly different outputs, just that in the case of C shell you don't have color for different kinds of things, for different kinds of files. Okay, how do you get out of this? You just say exit and you're done. You can run bash inside bash, and you can't really tell what's going on until you do something like this. This command ps, which we will explain later on, shows you that there's two bashes running. And if there is something like that, this is not always the case, but you can exit from one of them and you return to the old one. There's the corn shell, which the book talks about, but we won't really have time to investigate much of this. If you are curious, go ahead, check it out. Check out corn shell. Okay, so there's a lot more shells. I'm not sure which of these. Csis is not installed. Oops, let me exit back to bash and try it from here. Nope, it's not installed. We can actually install it if we have a network connection. I'm not going to bother right now. Chances are we have a shell just like bash, but much more compact and much faster, called dash. And that's running. If I do a ps now, I can see that in addition to bash, there's also dash running. These numbers are all important. We'll go over these things later. I'm going to exit out of this shell and that'll get me back to the basic shell that I was running when I started this terminal program. Okay, that's just to show you that besides logging into a system or starting this terminal program, you can start up a shell anytime by just running it from the command line. Okay, so you can try out, see which ones of these are installed, which ones of these are not installed. They're all, if you have a chance, they're all worth learning about. But just to emphasize, the only one that we're really going to use a lot of is bash. Okay, so it turns out there's two kinds of commands, built-ins and external. To look at, if you want to, a rough idea of built-ins is just that built-ins do not have a separate file that's used to run that command. It's part of bash. It's internal to bash. Bash can also run any other command that you have permissions to run. And so those are actual files. They exist outside bash, and they're called, we'll refer to them as external commands. There's a whole bunch of different commands that are built-ins. So let's take a quick look at that. You can find a complete list using man built-ins. So let's take a look at that. You say man built-ins. You see a list. There's a huge list starting from I guess from here, colon dot, which we may have used. This definitely we'll use in the next set of lectures on shell scripts. And then let me see, cd is one that we've used. So cd is a built-in. Also, I think we might have used echo very briefly. You can have if statements, you can have where are they? There's break, just like break in Java. There's also continue. We'll see a lot more of these much later in the next set of lectures on shell scripts. There's while loops, just like while loops that you might have used in Java. Okay, so there's a ton of stuff here, and this is just to show you that you can get more information about built-ins just by saying man built-ins. Okay, so like we just saw, there's two kinds of commands. Built-ins are part of the shell, things like cd. Externals are executable files. So let's take a look at that in a little bit more detail. So if you wanted to find the executable file that corresponds to a command, one way to do that is to use the command called which. You can say which ls, and this tells us that there is a file called ls in a /bin directory. So what this tells us is if we were to go to /bin using cd/bin and you do an ls, there's a ton of files here. These are all binary files that you can execute if you have permissions. Most of these you do have permissions. And one of the things that you'll find is ls. So you can run ls to find more information about this ls command. Here it is. It is a pretty large file, about 100K, and it's executable. That's what this X means. And it's owned by the super user. Okay, so compare this with the command cd. So we've used ls, so you just say ls, you get a bunch of output, you cd to your home folder and do an ls, you see all the files in your home folder. Now where is cd? You could try finding it. You could say which cd. There's also a command called where is, and it doesn't give you anything. Okay, so each of these commands, which cd and where cd, give you nothing back. The main reason for that is that cd is a built-in command. So if you were to go to man, built-ins, one of the things that you will see is cd right here. So this tells us cd is a built-in command, so you won't see a file corresponding to the cd executable because there is none. It's just built right into bash. Okay. So there are some built-ins that duplicate functions of external commands. Why is this? Because the built-ins are usually faster. So echo, it turns out there is an echo command that's an external file, but also bash has a built-in called echo. Not every shell will have all the same built-ins. Bash just happens to have these on the system that we are using for, that is in the live DVD. There's a bunch of other ones like pwd we've used. So once again, let's just take a look at that. You'll see pwd, it's right here. And if you say which pwd, turns out there is a file in /bin called pwd, even though there's also a built-in. And which one do you run when you say pwd? It turns out it's the built-in command. So when you say pwd, even though there is an executable file, that's not the one that's used. It's actually the built-in command, built into bash that you run with pwd. Okay, so it's just to once again, this is to show you that there are some commands that are also duplicated as built-ins because they're faster.